All right. So the real number system, rational numbers, irrational numbers, this can be very confusing. I'm going to go through it, try to keep it as simple as possible, but it's not a simple concept. So understand that as you get into it. But the real number system is made up of all the numbers in the real numbers. There's also complex or imaginary numbers, which we're not even going to talk about today. That's a whole other thing. But within the real numbers, it's all essentially all the numbers you've ever heard of, right? They all fit somewhere into this system. So we're going to start with the smallest group, which is actually a really big group of numbers, and it's the natural numbers, and it's the numbers that you've heard of your whole life, like 2 and 97, and I was about to write a 3, so I'll put 315. And anything that, when you were learning how to count 1, 2, 3, 4, 5, like those are all real numbers. And so they're specifically called natural numbers. Okay, so those are the natural numbers. Let's keep going, because natural numbers are a part of whole numbers. And the fun thing about whole numbers to me is that the only additional number in whole numbers is 0. That's it. And so I think of the O in whole to remember that that adds 0 to the list of natural numbers. And also, like, zero's like got a hole in it, right? When you write the number. So whole numbers are all the natural numbers plus 0. That's it. Let's keep going. Then you have integers. And with integers, you're going to see numbers like, let's see how this shows up. How well this shows up, like -5, -81, -2004, right? Any negative number. So integers are all the positive numbers, all the negative numbers, and 0. That's integers. That's all that means. And then you have what is just composed of all the rational numbers, which is everything you've seen so far, but it adds in numbers like fractions, certain fractions, and decimals. So rational numbers are, well, yeah. If a number can be written as a fraction, then it's a rational number. But it would also include decimals like 0.875 or 2.39 or even 1.47 repeating, right? If it's repeating, it's still rational. So those are all good, all rational numbers. If you have 8/6, that's rational. It's not simplified, but it is a rational number. So, okay. So all of these are rational. And now we're going to look at what is irrational. So I'm going to erase this for just a minute, since I want us just to kind of focus on what is irrational. So irrational numbers are numbers that cannot be written as a fraction. And, they're not written as like, they're not positive numbers or negative numbers simply. They are almost always going to include a square root. So the square root of 2 is irrational because the square root of 2 is this long decimal that doesn't ever repeat. It doesn't stop or terminate, right? The square root of 4 is 2. So the square root of 4 is rational, actually, which is kind of interesting. But it's only because the square root of 4 is just 2 times 2. So the square root of 4 is 2. So that ends up being a normal number. In fact, 2 is a natural number. So the square root of 4 technically gets simplified into that. See, I told you it wasn't simple, right? It's not a simple concept. But the square root of 2, there's not any nice, clean number, any nice, clean, natural number that you can multiply to get to by itself, right? To get to. So this is irrational, just like the square root of 7 is irrational, or the square root of 19 is irrational, because those are not nice, perfect squares. Okay. Another thing that's irrational is pi. you know, 3.14159, blah, 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 right? You've heard of people who memorize like long strings of the numbers in pi because nobody's ever found a pattern to it yet. Like there's, you know, it just continues and continues, and there's just this unending non-pattern of the numbers that it's equal to. And so that's irrational. So I think of the word irrational, I'm like, oh, if you're, you know, if something's irrational, it's not making sense. And that kind of blows my mind that pi never repeats. It just continues and continues, and there's never a repeat, there's never a pattern. Our brains like patterns. So I kind of use that to help me remember it. So there's irrationals. So I'm going to show you a nice cleaned up version of this. Hopefully it looks clean anyway. This one is just kind of has some examples for you. I'll put in the square root of 1/3 under irrational to show you that if it's a fraction, but it's underneath that square root symbol, it's irrational. So normally a fraction would be considered rational. Yeah. Okay. So hopefully that helps a little bit. I've got this in download. So if you haven't already downloaded it, it's right there in the dashboard under Foundations of Algebra. So you'll want to go to Algebra 1 resources, Foundations of Algebra, it should be there. Real number system. All right. And remember, don't let anyone think less of you because you're young. I'll talk to you later.